Hello, good morning. Yes, welcome to today's meeting. For those of us who are joining us, thank you. Kindly mute your audio. Okay. So give me just about a minute as I prepare everything. So I hope you're all good. So welcome to another episode of training, the Hawa DHSA versus certification training. So it's a continuation of our previous training. So today's training is part 3, not part 2 as early indicated in the training groups. So I'm preparing materials for presentation. Okay, so I hope everyone is okay. Today's the number is we're having about 8 participants. So I think we are now having those people who are focusing more on the certification. So we began with quite a number. Now we're having the serious guys who want to get the certification. Okay, as we proceed, I hope others will join us. I'll begin by introducing myself. My name is Shelton Kipkoech. I'm from the Tech Support Department at Dahawa Technology. So my contact are indicated on the screen. So for any inquiries, any question regarding Dahawa products, so I'm the guy to contact. So we also have other people from the tech team, but for the training part, I'm the one who will be handling most of the trainings. So our training today is about the HSA VSS certification, which you guys, if you have been a part of the training as we began, yeah, I think you're conversant where we are heading to and what we are doing. For those of us maybe who are joining us for the first time, we are doing a training for the HSA certification. So the HSA VSS is a certification for video surveillance system. So we are doing a progress on the same. So we have before we have been doing trainings on from the coursework. We have done a technical basic. We have handled the camera section of it. So these are the what our course entails. So we did a introduction to CCTV system. We have done introduction to camera. Now we'll be doing a recorder. So for you to get certified, you will need to do an exam on the same. So the exam is both theory and practical. So for the practical part of training, we have been doing practical trainings on Saturdays. So for the past 2 Saturdays, we have done practical training for those of us who joined us. And So we'll be doing practical trainings on Saturdays, but for tomorrow's case, we'll not be doing the practical part of it. We'll be doing, we'll still do online, because I've realized there is quite a lot of information we need to cover for the theory part. So we need to hurry up. So today's session will be 3 sessions of 30 minutes each. So yes, get prepared for the same. So I need to tell you early. So we'll begin with a 30-minute session to end at 11:30. Then we have a 15-minute break. From there, you just re-click the link. Then you join again we resume at 11:45. Then you take another break at 12:20 for 15 minutes or 10 minutes. Then we begin again. So I hope you're ready for the 1 hour, 30-minute session. So the exam will cover camera 20% theory, not 20, 40% theory. Then there will be 60% configuration. Considering it's a technical core training, you will need to know the actual working principle and configuration for the products. So you will know, you need to know how to do connection, installation, configuration, and troubleshooting. So at the end, when you pass the exam, pass mark is 60. So when you pass the exam, you get certified. So I think we'll provide an avenue for you guys to in case you need to redo exam even other times, we'll provide with you, we'll facilitate that for you to pass. Okay, I think now we can begin on recorder. We have handled before basic training. So for the camera section part of it, we are complete with that. So for those of us who joined us on Saturday, we were able to do the recorder part of it. So they're a bit ahead of the same, and also did a practical part of recorder. So today we're going to do the recorder section. I hope you can see that. Okay. So we did this section here. So let me highlight for you. So we have covered this part of it, this part of the training. Now we are at this part where this the NVR part of it and the recorders. So the recorders entails NVRs, EVS, and DVR. So an NVR is a network video recorder, and EVS is an embedded video storage. DVR is a digital video recorder. So difference, DVR works with the analog cameras, while NVR works with the IP cameras. So we also have, so the categories for the DVR include the DVR, HCVR, and XVR. So our modern one is the XVR for the analog part of which can also do, apart from doing the analog cameras, you can connect your IP cameras to the XVR. So an EVS is an embedded video storage. So typically application for EVS will be to use in situations where you need to have high storage. You need to maintain a record for the same. So where in the cases where you need have to recordings of videos for longer distance. So EVS will have hard disk slots where we have capacity even to up to 84, 96 hard disks. You can check that on our website. So the recorder working principle is that for the analog camera, since the camera outputs an analog signal, we need to do a conversion from analog to digital. Then you have to do encoding, then proceed to storage. Whilst for the IP camera, since we're receiving a digital signal, what the NVR will do will just do recording. So that's how for the functionality part, that's how you differentiate between an analog for an NVR or a DVR. So the working principle in detail is that for the analog camera, for the DVR, you have the analog camera at the front end. Then there is encoding, then there is recording. So basically, this is the information that I've summarized here is into detail is here. So some DVR support connect with network cameras, supports decoding. So that is the XVR. The XVR, which I've mentioned before, is the ones that can support even IP cameras, not limited to analog cameras. NVR working principle. So for NVR, you just connect the network cameras, which we said is the IP cameras. So the function for the NVR will just to do recording, decoding, transmission function. So the encoding case will refer to conversion from analog to digital. Since the IP camera has an output for digital signal, there's no need to do encoding. That's why NVR does not support encoding and cannot connect to analog cameras. So maybe you can consider at times you have clients where they have old system, and maybe you want to integrate IP system. What you can opt for is an XVR because it can support both the analog cameras and the IP cameras. So another advantage of XVR would be you are not only limited to analog cameras. You remember when we were talking about cameras, we did talk about different types of analog cameras. So you have the analog cameras, and you have the analog modern cameras that support high resolution, even up to 4K via coaxial. So the advantage of XVR will be that case. Also, the disadvantage of XVR for the cases where you need to do high intelligence and you need to do a bit more processing of information for AI, you would not go with the XVR but NVR. So XVR is more of middle small to medium-sized organization where you can do the AI functions, but not, it's limited, not that much. Okay, going to next, going to do about the coding knowledge. So in case there's a question, you can put it in the chat section. If there's something that's not clear, you can also confirm that. You can ask at the chat section. So how the NVR or the recorder receives information, there's a methods for the scanning model. So a scanning model refers to how the images, that is the video, has been taken into the system. So we have different types of scanning model, progressive and interlaced scanning. So basically a video is a series of pictures that are shown very fast on your side. That's why we call it frame rates. If we say 30 FPS or 25 FPS, means 25 pictures per second. That's the frame rates per second. 25 pictures that are per second that are being shown that are being shown to you to give the impression of video, whilst it's just a continuous series of images shown very fast. So how are those images shown very fast to you? So we have in progressive scanning or interlaced scanning. So progressive scanning is a method of scanning. Maybe for those 25 pictures, you will be shown each frame in sequence. So you go to frame 1, frame 2, frame 3. So that sequence. Well, in interlaced scanning, you do odd lines, then even lines for each frame. So meaning you can begin with frame 1, 3, 7, up to 25, like in the order numbers, then go back to frame 2, the even part of the frames. So there are advantages and disadvantages for each type of scanning method. So in the video field, if one of the many still images are displayed sequentially to create impression of motion, the script, yeah, talk about this. So the scanning, okay, you need to just know about the scanning methods that are used with the recorders. So about the progressive and interlaced scanning. So I hope that is clear. Video standard. I think this is when you are setting up an XVR, when you're initializing for a recorder. Basically, different methods. There are different types of video standards, and the reason why we have different types of video standard is of importance, because I found some people you do a different standard, whilst it's not required there. So a video standard that we use in Kenya is PAL. The reason why we do use video standard as PAL is because our power frequency is at 50 Hertz. So the power frequency that we use in Kenya is at 50 Hertz. While in other countries, we have different Hertz for different, like in USA, they're using a 60 Hertz. In Japan, they're using power frequency of 60 Hertz. That's the AC. So you need to ensure your systems all run at PAL. So advantage is that by default, when you do initialization of device or selecting region, you would select your country and you would have the video format as PAL. So for those of us who are with us on Saturday, we tried changing the power frequency of a camera to a different value, like 60 Hertz, while the recorder was doing a power frequency of 50 Hertz. So when we did that with the HD camera, what happened is that the camera went off. So you need to consider the power frequency. Also, in cases where you are experiencing flickering and out of step, where you have like the lamps in the display, check your the video format setting. It's a very important part while doing installations. So consider that. Okay, network camera video stream. What is a stream? So a stream is basically the output for the camera. So is the compressed image or data used to evaluate data volume in an instant time. So the stream is measured in bit rate. So higher resolution, higher frame rate means more data and greater stream. So the stream is the signal that you are receiving from the camera. So if you have higher stream, meaning you have higher quality, higher frame rate. So there are different type of streams that we receive from camera. That is the signal. We have a video stream, audio stream, and a composite stream. So a composite stream is it comprises of video and audio. So we also have our devices. You have a HD cameras that support composite stream, meaning you have transmission of video and audio over coaxial cable. So an IP stream can give more than one video stream and different resolutions. So you see when you are doing the, for those of us maybe who have experience with the recorders, there is the mainstream and substream. So for a mainstream, you'd configure mainstream to be higher resolution, higher bit rate. The substream is a lower resolution, lower bit rate. So at times you might be experiencing in mobile phone that you're trying to view the video, but it's hanging. So you just switch the stream. So you go to a lower quality and the lower frame rate for you to view on a mobile phone. So as much as we're talking about stream, we need to put into consideration factors like compression. So at times the signal from the camera is quite large. So we need to do a compression for that signal and get the optimum, or as much as we are trying to reduce the size of that stream, we still retain quality. So we have different types of compression that our products employ. We have H265, we have H264, we have even AI coding. So our latest type of compression that we try to handle the signal from the cameras, the recorder, we have AI coding, which is not mentioned in this training. So the coding technology we have H265 and H264. So stream control technology, we have two CBR and BBR. We'll talk more of into detail as we progress about this too. So H264 compression is a type of compression which considers the former and latter pictures into consideration. That is, the frame number 1 and the frame number 25. In between those frame number 1 and maybe frame 25, if you are doing a 25 FPS, what the system will do to compress will only consider the sides that are moving. So for this case, if you take this example in the screen, this example in the screen, from the first picture here, you would see that the compression technology will check the whole picture. In the next frame, what it will do, it will realize that the house is not moving. So it will not take the signal with the image, rather consider the person moving. So the frame that is retained is the person, while this house is discarded. It will continue the same. Then at last, it will combine the former and the first and the last frame, and the moving parts of each frame in the middle part, and create the output result, which is compressed signal. So what is reduced from the signal is the non-moving parts. So if that is clear. So if there is a small rectangle moves, H264 will record the direction, distance, and the rectangle itself will not be compressed twice. Yeah. So the signal that is transmitted, you can see from the green signal and the not transmitted. So the house is not transmitted, this person transmitted. So the moving parts of the signal. I hope that is clear. So that's how H264 works. So video encoding technology. So while we are doing this this compression here, transmitting and not transmitting signals that are not moving, or the stagnant frames in the picture, you need to know which type of frame is this, which type of frame is this. So in this case, the I frame is the initial frame. You see this first picture here. So this is the I frame. Then the frame that is compressed from this case will be the P and the B frame. So the I frame contains full image data. When transmitting the I frame, the stream will be large. When transmitting the P frame and B frame, the stream will be small. So typically, I frame will be located from the first and the last side. So at the last section, it will combine all the frames to create video impression. So P frame is predicted picture and B frame bidirectional predicted picture. Only all the image information. So this is a bit confusing, but that's hope that is clear. So another encoding technology apart from H264 is H265. So H265 and H265 plus. So the principle working for the compression technology is more of the same. However, when using the H265 or H265 plus, you can see the utilization for the storage is better. So if you're using H265 plus, while in the case where you'd use maybe about 100 hard disk with the H264, you'd only use one hard disk with, is it 1 or 10? 10 hard disk with the H265 plus. So the higher the compression technology, the better the hard disk utilization. So whilst doing compression, ensure that you maybe set to put your settings to high compression. So these are one of the things that you can do on your side to make utilization of hard disk or have more retaining information, apart from maybe doing recording on motions. So so the stream control technology. So we're saying the camera has an output signal. So how do you control that? How do you control that signal from the recorder side? So the recorder can do a constant bit rate or a variable bit rate. So the advantages, there exist different advantages and disadvantages for each control technology. So typically, most of the people will use constant bit rate. So if you're using a constant bit rate, it's predictable in terms of calculating the storage that you need, and also other factors. So is almost. So if the stream ends while I'm presenting, then you'll just resume at 11. So different applications. So if you're using a CBR, the stream will be steady. The picture quality will go down when the video has a lot of dynamic information. So using a VBR, picture quality is good, even if the video has a lot of dynamic information. Disadvantage of VBR, the stream will be large. So meaning higher stream, higher bit rate, less hard disk utilization, needs more storage when the video has a lot of dynamic information. So for cases, so e.g. for indoor scenes, due to less moving objects, configuration stream is 2 Mbps to meet the requirements. For road monitoring scenarios, due to scene changes, you may need to configure bit rate to 4 Mbps. So if you enable a VBR settings on your recorder, you'll be able to configure the various parameters for quality and the bit rate. So next, we're going to do hard disk and RAID knowledge. So I hope everything is clear from this section from the beginning about introduction, working principle, and coding knowledge. We're going to do about storage information and HDD and RAID. So hard disk introduction. So we have different types of hard disks that we use. We have PC hard disks. These are normal hard disks that you install in a desktop computer. Surveillance hard disk or enterprise hard disk. So PC hard disk will include even the small hard disk. So at the moment, the employment of SSD with the recorders is not there. So, but for the hard disk, we have the big hard disk for the desktop and the small hard disk for computer. So the small hard disk will typically be used in scenarios where you are using a recorder that is the MNVR, the mobile network video recorder. So for MNVR, it will use that small hard disk, while these other recorders will use that big hard disk. So for recorders, we advise you to use the surveillance hard disk because different types of hard disk adapt to different situations. So for cases where you have a PC hard disk, you would mostly do a lot of reading and a lot of writing. So for surveillance hard disks, you're going to use to do a lot of writing operations, that is putting information into the hard disk. So less reading. So that's why you should have a hard disk that supports better writing capacity while doing surveillance hard disk. Enterprise is HDD. So it's more of the same about surveillance hard disk. However, this one will use with complex systems and high-end devices. So the capacity for hard disk is basically what size of information the hard disk can support. So we have different ones about 6 TB, 4 TB, 10 TB. Yeah. Oh, we also have hard disk for Dahua. So Dahua also sells hard disk. So apart from using Seagate and other brands, you can use Dahua's because it's optimized for surveillance and for the enterprise cases. So different types of interfaces that the hard disk have. So have IDE, SATA, SAS. So I think you can search about this one, but it's not that not a complex information. Basically, how if for the case where you have an hard disk, so you see at the connection point of the hard disk, we have different interfaces. So we have SATA, SAS, etc. So the most one that we use is the SATA interface. Maybe someone can tell us about the SAS. So hard disk comparison, PC, surveillance, and enterprise. So a surveillance hard disk power requirement is 2 amperes, while a PC hard disk is greater than 2 amperes. So if you're having a recorder like a DVR or XVR that has 12 volts input and 2 amperes, if you take a PC hard disk, most likely you will damage the recorder. If you use a surveillance hard disk, it uses less power, meaning the recorder will perform. So hard disk is a very important, because at times also we have clients coming that you have installed a hard disk, but the mouse is not working. If you remove the mouse, the hard disk, if you remove the hard disk, the mouse is working, because the type of hard disk you're using basically affects the system. So go with the surveillance hard disk or enterprise hard disk. So for the cases where you're using enterprise hard disk, also ensure that you are using power. The power that you're supplying meets the requirement. So talk about this one about working more, reading more, write less, write more, read less. So because you're recording information, you're going to do a lot of writing, and displaying is less, that you'll do a lot of display, fetching information from the HDD. Okay. So video storage capacity. So for those of us who are not with us, we are in hard disk knowledge. We have done about codec knowledge now in HDD information. So video storage capacity. So basically, this one will help you to do to predict your storage requirements for the system. So we continue at 11:40, sorry. So we're going to have a 5-minute break. I'm going to end this meeting, then you'll just click the link that we sent. We resume at 11:45. So we'll resume at 11. So any question, any concern? Okay, we'll resume at 11:45 for the same.